So let's understand LCM of polynomials actually. Let's first understand HCF of polynomials. First of all, let's revisit the concept of HCF also. HCF of polynomials we are going to learn now. So say let's understand the HCF concept if we have forgotten. So it's HCF is called highest common factor, and say if you have a number say 24 and you have another number say 36, and then I need to know the HCF of these two numbers. Right now I'm talking about the HCF. So how do we go about this is we try to factorize it in prime factors. So we start with this 2 and then we get 12, then we again do this, we get 6, we do this, then we get 3. So this is 2 to the power 3 into 3 is what we get for this. And 36 again, we start with 2, we get 18, we do this 9, we get this 3. So what we get here is 2 square into 3 square. Now what will be the HCF of these two? We take the basically highest common factor. So for 2 to the power 3 and 2 to the power 2, what is the highest common factor in these two? For 2 and 2 to the power 2, which one I can take? Basically, can I take 2 square when 2 square is in both of them, right? Similarly, 3 to the power 1, I can take common from both of them in a way. So 2 to the power 2 into 3, which is actually 12, is the highest common factor for these two. So this is the factor which can divide 24 and 36 both, is what we are trying to get over here, right? And to do that, what do? We take common, whatever we can take common from both of them. So here, from here I can take 2 square common, from here I can take 3 common. So this is the common factor is 2 to the power 2 into 3, which is gonna be 12. Okay. Okay, now let's do the other one as well. So let's find out uh, highest common factor for say 36 and 144. What will be the highest common factor for 36 and 144? Power of that. So this is actually I've written over here. This is 2 square into 3 square. Okay. So see, let's do this. If I do this, I start with 2. I get 72 over here. If I again use a 2, I'll get a 36 over here. Then I'll use 2 again. Then I get 18. Then I use 2 again. Then I'll get 9. Now I cannot use 2 anymore. Then I go to the next number. Next prime number is 3. Then I divide by 3. I get 3. Then no more. So basically either you do this 3 and then it will be 3. So the factors here would be 2 to the power 4 into 3 square. Isn't it? So now what can I take common from both of these? What can I take common here? 3 square, isn't it? So this is 2 square into 3 square will be 36. Actually, the interpretation of HCF is that what is the basically highest common basically divisor of both of them. So if you look at 12 will be able to divide 24 and 36 both. But is there any other number which can divide both? I mean, there will be no number. Similarly here, the largest number which can divide both of them will be 36. 36 in one time it will divide it, and here if I do have to do it in 4 times it will be able to divide. So this is the interpretation of HCF. So let's do one more and then let's see if we got this. So I've got say 81, and then I've got 3, no, not 343. I've got 243. Okay, so for this one you got 3 to the power 4. For this one you've got probably 3 to the power 5. Okay, so what will be the highest number which will be common to both of them? 9. This is 99. This is 993, isn't it? Okay, so what will be the highest common factor I can take from both of this? So basically see here, 81 is the number which can divide 81 as well and 243 as well. I mean, that's how we actually understand HCF. Okay. So when how do we do it is basically what we do is, again, let me just tell you again. So 2 square, this 24 is there, right? So what we have here is 2 cube into 3, and then let's write this number 2 square into 3 square, and think that what can I take common from both of them. So if I take 2 square into 3 common, what I'll be left with here is basically 2. What I'll be left with here is basically 3. So this is how we understand. I mean, I cannot take anything more common over here. Okay, so in this case the highest common factor was 2 and it divided 24 in 2 times, while 36 it divided 36 in 3 times, while for the other number which we did over here, 36, 2 square into 3 square and 2 to the power 4 into 3 square. So here I was able to take 2 square common, and then here I was able to take 3 square common. So what I was left with here is 1, and what I was left with here is 2 square. So then this number is basically 36. It divided 36 in 1 time, while it divided 104 in 144 in 4 times. Okay, similarly same thing over here. I mean, you will get confused if you are putting it in this format. You got to put it in the smallest divisor format, as in like try to put it in these kind of numbers 2, 3, 4, 5, because they are the basically prime numbers and they cannot be reduced any further. Okay, so there will be no confusion here. Okay, so that's the way you go about. First you start with 2, then go to 3, then go to 5, then go to 7, then go to 11, then go to 13, and that's the way we go about generally factorizing all these numbers. Okay, when you do not have anything common, right, what do we do in such cases? For example, if I'm asking you to get a highest common factor for numbers like, say I've got 16 and then I've got 25, right? If I've got these two numbers, then 16 I can write it as 2 to the power 4, while 25 I can write it as 5 square, and there is nothing common over here. So in such case, we say that the highest common factor is 1. So I mean, every time I can just think that it is 1 into 2 to the power 4, and this is 1 into 5 square. So basically, in cases where these two numbers are co-prime to each other, right? In such cases, the highest common factor is 1. Okay. If we are okay with this, let's go to the next concept. I mean, in the same thing. Now we are trying to get the highest common factor of polynomials. So we will be working with polynomials. Let's say I have a polynomial 24x square. I have one polynomial, and another polynomial I have got is, say, 23. No, say I've got 28x. So if I have to again find a highest common factor, it's more like I want to take something common from here. So first I have to reduce it into these two into two things. As in like I have to treat this as separately, treat this as separately. Or I can think 24 as 24, I'm just writing it separately. So this 2, I am dividing it by 2, I get 12. I am dividing it by 2, again get 6. I am dividing it by 2, I get 3. So I am writing 24 as 2 to the power 3 into 3 to the power 1 into x square. Here gx I am writing 28 as 28. Again trying to factorize, I got 14. Again I got 7. So I'm writing it as 2 to the power 2 into 7 to the power 1 into x. So what can I take common from here and here? What can I take common from both of these? X square, can I write x square as x into x? So can I take x to the power 1 again? Case what is the highest common factor is 2 square into x, okay, which is nothing but 4x. So if you want to divide this by 4x, you will get what back? You will get 2 into 3 into x and 6x back here. So px can be written as 4x into 6x as well. So, and similarly, gx can be written as 4x into 7 as well. So when I divide, so in this way, you can see that 4x can be taken common, and when I divide it by 4x, here I'll be left with 6x, and in the other case, I'll be left with 7. Okay. So now let's try to complicate it a little more. Uh, say if I have got px equals to uh, say I've got 25, and then I have got here x square in, and then I have also got say a square as well. A square is again another constant, and here let me just put it in a different. Let me put some constants right away. So let's say I have got here 25 a square b cube, and then I've got x to the power 5, and I've got qxs 24 a to the power 6 b to the power 1 and x to the power 9. Right. So 5 square, I'm writing it 5. Try 2. What will I get here? If I divide it by 2, then let's come back to the number. 5 square here, there is no 5 square here. 2 cube, 2, there is no factor of 2 over here. 3, there is no factor of 3 over here. So of course, none of the numbers can be taken common, and then that will be that. Okay, don't get confused that you have to. If there are no numbers which are looking common, you cannot take common. That's it. It's the same thing. If you want to take, it's the same numbers which I've given you, 25 and 24. If you remember, we were trying to do highest common factor, and there were nothing common. When even here 16 and 24, if there is nothing common, I mean, you just say that one you can take as the highest common factor. You can put one, don't put one. I mean, doesn't matter. If you want to have something common taken for the numbers, you can just put a 1 here, which is again simply not putting it there as well. So you will get square into b into x to the power 5. So yeah, so we have got something which is called highest common factor. And why do we do that? As in, like, let's understand. So see, whenever we are working with expressions, right, we will see that these things will be required for us to do. For example, say say you have got basically two expressions again. Px, I'm just going to write this as uh, something like this, x square into x minus 1, and then you've got qx again as x to the power 3 into x minus 2. And say if I have something like this expression px plus qx, someone is telling me to evaluate this expression, what we can do here is we can write x square into x minus 1 and then x cube into x minus 2. And all that we are wanting to do over is that we want to take something common, and this is what is basically highest common factor. So here we can say that x square x cube is there, so I can take x square common. When I take x square common, what I'm left with here is x minus 1. I write it like this, and then here, since I'm left with x and then x minus 2. So when I'm multiplying it, I will get back the same expression when I expand it. So this way we try to simplify the numbers also at times. So here you can write this expression again as x square into x minus 1 plus x square minus 2x. and then this can be written as x square into x square is minus 2x and this plus x will become x square minus x, and this will be a minus 1. So this expression which was looking like this can be reduced to this expression as well. And mean, uh, coincidentally, we have used the understanding which we have got over here, that how to find the highest common factor. And in this case, it had been simply x to the power 2, but it could have been even here, like 25x square here, and here it could have been 24x cube. And in that case, we had to know that we can take these two numbers as well common if there are some common factors. So this is what we were trying to understand more from HCF perspective, but it is going to be used to actually what you call solve some expressions which you come across later. All right. So this is what was HCF. Let's do some examples from the book also. Okay. Check this one. Second the HCF of 24a square b and 32ab square. Can you figure out what would be the highest common factor? So the expression was 9a square 9a square minus 16b square. A little bit thinking was required 9a maybe. And then the next expression was 12a square minus 16ab. Okay. So whenever we have this, right, we try to put this expression into some sort of factor, right? Here this number is looking very more like a summation, right? But if you look at this very closely, this 9a square can be written as more like 3a whole square, and similarly this 16b square can be written like 4b whole square. Okay. Now this is looking like a square minus b square, so it will be a plus b into a minus b, this identity. So 3a plus 4b, and this will be 3a minus 4b. So now this number is reduced to some sort of factor, and if I have to get HCF, then I'll try to get some factor which is common. Now here again I will try to look at what can I take common, and I mean I can take, if I have to write 12, I will write 2 to the power 2 into 3 a square, and this will be written as 2 to the power 4 ab. What I can take common from both of these is basically 2 to the power 2 into a I can take common. So here I will have something like 3a, and here I'll have something like 4b. Now this expression is reduced to 4a into 3a minus 4b, and this expression is reduced to 3a plus 4b, 3a minus 4b. Can you see
Yeah.
3a minus 4b is common in both of them? What is the HCF?
Okay.
So to get to HCF, first it has to be factorized, right? Wherever we
Mm.
were trying to do HCF, you would remember that we were trying to factorize it, right?
Mm.
So this is what we did, and now we got the expression. Oh,
Okay.
there is another problem just now I saw, and it is again requires a little bit of thinking, but it's good to do this practice. So read this question. 8, number 8. HCF of x plus 2, this expression. So this is, there is an expression, okay? So there is an expression x plus 2 into x squared minus 7x plus k, and then there is another expression x minus 3 x square plus 3x plus l. Now they're saying that for both of these expressions, the highest common factor is x plus 2 into x minus 3. Okay, they are saying this is what it is. Actually, they have given you the final result. The HCF is this for these two expressions. Okay, now they are saying that if this had been the case, can you find the value of k and l? What will be the value of k and l if this expression and this expression has highest common factor as x plus 2 into x minus 3? So yeah, so what they are saying here is that they have given you the highest common factor already, which is x plus 2 into x minus 3. So if I am saying this is the highest common factor x plus 2 into x minus 3, does this mean that x plus 2 and x minus 3, both of them should be here and here, right? For example, here 3a minus 4b was the highest common factor. So 3a minus 4b is here as well and 3a minus 4b is here as well. Isn't it? If I'm saying that x plus 2 into x minus 3 is the highest common factor, then x plus 2 into x minus 3 should be here. So somehow this thing x square minus 7x plus 5 is having a hidden factor x minus 3. Then only I'm able to take this common, right? Similarly, on this one, this has got x minus 3, but I'm not seeing x plus 2 here. So somehow this is also going to have x plus 2 as a factor. Okay. So now it is reduced to, this problem is reduced to this, which we learned in the last class, that x square minus 7x plus 5 is divisible by x minus 3. So if I'm saying that px, for example, is x square minus 7x plus 5 and it is divisible by 3, does it mean that if I put p3, then this will become 3 square minus 7 into 3 plus, this is k, not 5, uh, plus k should become 0? Can I say that?
Yes.
Okay, so in this way, can I say this 9 minus 21 plus k is going to be 0? Or can I say that k is going to be equal to my plus 12? Here it is minus 12 and then I'm sending it on the. So k has to be 12. Then only then x minus 3 will be a factor here. And similarly, can you do the same reasoning over here and tell me that what would be the value of L? Minus 2 square plus 3 into minus 2 plus L should be equal
Yes.
to 0. This should be equal to 4 minus 6 plus L equal to 0, or L should be equal to 2. Okay, so you can see here as well, if you put x square plus 3x plus 2, then you can factorize it and this will become x square plus x plus 2x plus 2. This will become x plus 1, and I take common 2 and this will become x plus 1. This will become x plus 1 into x plus 2. Okay, as I can see here that x plus 2, I can see a factor. Similarly, if you put 12 over here, it can be factorized into 5 and 2 or 3, whatever. I mean, just figure it out. 4 and 3 probably. 4 and 3, and then I'll be also getting x minus 3 over here. Okay. So, first thing to understand here was that HCF being x plus 2 into x minus 3, it means that I'm able to take common x plus 2 into x minus 3. It means that x minus 3 is somewhere hidden in this one. So to get this is what we did, and x plus 2 is hidden here, so I'll do this. Okay, this was question number 8. Okay, all right. So with this, let me just move on to the next concept, which is called LCM. We'll try to understand LCM as well, and then we'll see what to where to make use of LCM as well. So this is LCM, which is LCM of polynomials. We are understanding this. And here LCM is again least common multiple. Oops. This is called least common multiple. So let's see if you remember. Can you tell me the LCM of say 4 and 6? LCM of 4 and 6.
Mm.
Okay, so 4 is going to be 2 square, and then 6 is going to be 2 into 3. Okay, so what will be the LCM here? 2 actually would be the HCF. Okay, so here we are saying that least common multiple. So further think this is least common multiple. Again, the number which would be divisible by 4 and 6 both. It's other way around. Number which will be divisible by 4 and 6 both will be the least common multiple. So in this case, what we do, we try to take the highest common factor from here. Not highest common factor, but the highest value of the prime factors. So in this case, the common number was 2 here. So the highest, this is not common, but the highest power. So I take highest power of this is 2 square. Then 3 is not available here. So simply I will multiply it by 3. Okay. So now this 2 square into 3 will be 12. So what is the interpretation of LCM? So LCM, so the nearest number which can be divisible by 4 and 6 both. Okay. So it's like I'm trying to divide a number which will be divisible by 4 and 6 both. So 4, if I am just going to write the table for 4, the first number is 4, then number is 8, then the number is 12. When I'm going to write the table for 6, the number first is 6, then 12, then 18. So then I'm looking at the least common multiple. So 4's multiples are 4, 8 and 12. 6 multiples are 6, 12 and 18. So this is the number which is common to both of them. Then I take this way.
Okay.
Similarly, let's go back to the highest common factor and then try to interpret that. Highest common factor, right? So though we did it in this fashion, let's understand. So let's say 24 and 36. So similarly, 24. So let's look at the numbers which will be able to divide 24. So 1 will be able to divide 24. The next number which will be able to divide will be 2. Then the next number will be 3. The next number will be 4. Then 5 will not divide. 6 will divide it. 7 will not divide. 8 will divide it. 9, 10, 11, 12 will divide it. And then next will be 24. Then I'm looking at 36. So the numbers which will be able to divide it. So I'm looking at the divisor of 24, divisor of 36. So 1, 2, 3, 4, 5, no, 6, 7, no, 8, no, 9, yes, 10, no, 11, no, 12, yes, 13, 14, 15, 16, 17, 18, yes, 19, 20, no, 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 36. Okay. Now here we are looking at the highest common factor. So the number which is very near. I mean, so we come from this side. So 36 no, 18 no, 24 no, 12 yes. Okay. So what I'm looking at is the number which will be able to divide highest common factor, which is 12. The method to find it is what we did is finding the common numbers, and here we have got 12. Okay, what are we doing in least common multiple? We are writing the multiples of 4, 4, 8, 12, and then we are looking at the least number. So we will be working from this side. 4, no, 4 is not here. 8, no, not there. 12, yes, it's here. 6, okay, this is also there. So 12 is the one. And the method to find it is that we try to find the highest power of the basically common factors, and then wherever there is no common factor, we just simply multiply the number. So similarly, if I have to find out, say, the least common multiple of 16 and 25, in such case there is no common factor, so this is going to be 2 to the power 4, this is going to be 5 square. Then what is going to happen is that the LCM of such numbers are just the multiple 2 to the power 4 into 5 square, which is going to be, because there is no common factor, so 2 to the power 4 will come, 5 square will also come, and this will be simply a multiplication of these two numbers, and this will be how much? 525. So this will be 300, isn't it? So 300 will be the least common multiple, and same way you can write 16 table, and then you can reach to that level. Uh, 400, is it? But just this is 400 actually. 400. So you can write for 16 table, and then you'll reach to this level. And similarly, 25 table, when you write, both of them will have this number, which will be the least common multiple. Okay. So if you have understood this, let's try to put some two numbers and see whether you can get the least common multiple. So my next numbers are uh, 10 and 15. We have to find the least common multiple of 10 and 15. Let's move
Yeah.
on to figure out the least common multiple of some expression which is in polynomial terms. So now if I have an expression which is like 6, not 16, let's put some numbers which is 8 a square b cube, and then I have got uh, 16 a to the power 3 and b. So what will be the least common multiple here? Okay, here what we have to do, we have to take the highest, basically the least common multiple, right? So 16 is fine because this is 2 to the power 3, this is a square, this is b cube, and this is 2 to the power 4 a cube and 2b. So when I'm looking at 2 cube and 2 4, I take 2 4 out. Then I'm looking at a square and a cube. What should I take in the same bin? What should I take here? If I'm comparing 2 to the power 3 and 2 to the power 4, but I'm taking 2 to the power 4 here, so what should I do here? We have to find out the least common multiple. Just work with some numbers first. So let's say I'm asking you to find the LCM of 25, and let's say I'm giving you three numbers. Find the LCM of 25, 16 and 49. Okay. So this is what is been given to us. So when we have to find the least common multiple of these three numbers, what we do? We try to factorize it, and then when I factorize, I'll get 5 square here. For 16, I'll get 2 to the power 4 here, and then for 49, I'll get 7 square. Now, when I am supposed to find the LCM, right? What we do, we write all the numbers, all the prime factors which are coming first. So simply, I'll write 2 into 5 into 7 first. Okay, and then we look at the highest exponent of all these all these uh, highest exponent of all these prime numbers. Okay, so for 5, the highest exponent is 2, so I'll put 5 square. For 2, it is 4, so I'll put 2 to the power 4. For 7 is 2, so I'll put 7 square. So this is the way to find the LCM. So similar way, if I had to do it over here, so what are the distinct numbers or the constants here are basically 2, a and b. So first I'll write 2 and b, and then I'll look at, okay, what is the highest exponent here? So highest exponent of 2 is 4, so I'll write 2 to the power 4. What is the highest exponent of a? Highest power of a basically 3 is here, so I'll write 3. What is the highest power of b here? So I'll write b to the power 3. Okay, so this is why I got LCM of this. Similarly, let's go back and try to see here. So if I had to get the LCM of 4 and 6. So first of all, I'll look at the distinct prime factors here. So distinct prime factors are 2 and 3. So first I'll write 2 into 3. Then I look at what is the highest power of 2. So highest power of 2 is 2. Highest power of 3 is 1. So 3 to the power 1. So this is why I'll get 12. So in this way, now look at this expression also, the final expression here. Okay, which we were working with. So we are working with this. Okay, sorry. We were working with this. So let's first try to factorize 96. So 96 is basically what? 96 is 2 times 48, then 2 times 24, then 2 times 12, then 6, then 2, 3. So this is 2 to the power 5 into 3. This is 2 to the power 5 into 3. Now x plus 1 is okay. So I'll write x plus 1 whole square. This is already done. This is x minus 1. This is okay also. This is x plus 3 to the power 3. Now I'm looking at 64. So 64, since I know this is going to be 2 to the power 6, I'm not going to do it. Now x square minus 1, I'm going to write x square minus 1. I'm trying to factorize it x minus 1 in such a way. Then I'll get x minus 1 into x plus 1. It's more like this is a square minus b square, which is nothing but a minus b into a plus b. Why I did it? Because I could see x plus 1 and x minus 1 over here. So this is why I want it's somewhat hidden in this form. So I'm just putting it back in this form. And I've got x plus 3 and x plus 2 whole square. Now let's look at the distinct uh, numbers or prime factors or expressions here. So one is 2 here, so I'll write 2 distinct. Then I have 3 here, so I'll write 3 first. Then I have got x plus 1, so I'll write x plus 1. Then I've got x minus 1, I'll write x minus 1. Then I've got x plus 3, I'll write x plus 3. Then I also got x plus 2, I'll write x plus 2. Now I look at 2. What is the highest power of 2? Is 5, so I'll write 5. What is the highest power of 3? 1, so I'll write 1. What is the highest power of x plus 1? This is 2, so I'll write 2. What is the highest power of x minus 1? Which is 1, it's okay, 1. X plus 3's highest power is 3, so I'll write 3. Yes, x plus 3 to the power 1. And then x plus 2, oh, the highest power of x plus 2 is square, so I'll write x plus 2 square. Okay, so now this is what will be the final answer. This will be 2 to the power. So this is where I made a mistake actually. 2 to the power 5 and 2 to the power 6. The highest power is 6, so 2 to the power 6 has to be here. Okay, so 2 to the power 6 should have been here. 2 to the power 6 into 3, which will be 192. This is 192 into x minus 1, x plus 1 whole square, x plus 2 whole square, x plus 3 whole square. Okay, now this is what is your expression of LCM. Find the LCM of 18x square y square and 8x cube y square. Find LCM of these two. So first of all, I'll have to factorize it. So I'll factorize 18 to 2 into 3 square, and this is x square y cube. This will be 8 is 2 to the power 3 x cube y square. Now can you see that there are like 4 distinct uh, what do you call numbers and expressions actually. So 2, 3, x and y, right? So I'll write 2 into 3 into x into y first. Now I'll look at what is the highest power of 2 here. Highest exponent of 2 is 3. Here 2 to the power 1 is 2 to the power 3. So I'll take 2 to the power 3 here. Here it is 3 square. There is no 3 over here. So I'll put 3 square here. Here it is x square. Here it is x cube. So I'll put x cube here, because x square and x cube, the highest power is 3. Similarly, here is y cube, here is y square, so I'll put y cube because y to the power 3 is greater than y to the power 2. Okay, so this will be my LCM. If someone had asked me to find an HCF of this, so I should have just taken the same way, but here I could have taken the common one. So if I had to write, for example, if I had gone about writing it in this way, 2 into 3 into x into y, 3 is not here, so I'll have to remove 3. So this is where 3 will not come into picture. Okay, so finally, if I have to take HCF, I'm just working with HCF, just trying to remind you that what is the difference here. So here, when I'm taking 2 and x and y, I have to take the least power of 2. So 2 power 1 is the least one over here. X square and x cube, 2x to the power 2 is the least power. Y cube and y square, 2 is the least power. So here 2x square y square is basically the HCF, while the LCM is 2 cube x 2 cube 3 square x cube y cube. And what it means is that 18x square y cube would be able to divide it. So if I'm putting this number, this will be to 8 into 9 will be 72 x cube y cube, and if you want to write it, it will be 18 x square y cube, and then what is left here will be 4 into x into, no, there is no y, so this is 4 into x. So this number will be able to divide LCM. This number will also be able to divide LCM. So in terms of 8x cube y square, if I have to put this, I'll have to put else again. This will be 8 into x cube y square if I have to write. Then this, what I'm left with is 9 into x is gone, and this is y square, right? Then y. So the LCM is the least common multiple. It means that these two numbers will be able to divide, and to get to that level, what we have to do is we have to take the highest exponent of the all the distinct basically factors which are there. All the distinct factors have to be written first, and then we have to put the highest exponents. Okay.